Hello, this is the Blast Report podcast on all things blasting. My name is Thibaud with New Wave Consulting, and I want to thank all the drill and blast teams along with those supporting them who are out there on the pattern. The production team at Blast Think and I would like to welcome you to today's episode of the Blast Report podcast. Happy to have you. We're out here in Tennessee on a project out here for TBA, and it's my first time meeting you, Mike Ballance, and got Mick Fritz here as well. And it's his first time on the show, but we'll do a different episode with Mick.
From Indiana, Pennsylvania.
That's right. Yeah. And so I guess it would be.
He and Jimmy Stewart were neighbors. You probably didn't know that, did you?
That's true. Indiana, PA.
Really?
Yeah, that's where Jimmy Stewart's from. Yeah.
Yep.
Sure is.
And he's a little more famous, right?
Oh, Jimmy Stewart.
Now, who talks more? Who talks more? You or Jimmy?
No, Mick does. Yeah. It just Mick doesn't make as much money per talking as what Jimmy Stewart
That's
did.
right. Okay, that's
there
right.
You go.
Yeah.
So, I guess it would be good for our listeners just to get how we start our guests is more of an origin story. Mm-hmm. So, what made you get into blasting and the explosives, Mike? Was it family?
No. So what I was working at the production plant in Wolf Lake, Illinois, and at that time it was a full line distributor. In other words, we made all facets of explosives. It was called Trojan U.S. Powder, which then became Trojan INC, International Minerals and Chemicals. But Bob Levan, which was the plant manager at the time, I was just finishing up in my last semester of college, and Bob said, well, now that you made this stuff, do you want to go out and shoot it? And I said, sure. What guy wouldn't? So he said, okay, so I want to transfer you to West Virginia. So I went to West Virginia, didn't know anything about it other than I know the stuff went boom. That was pretty much it. And I went to Valley Quarries in Chambersburg, Pennsylvania. My very first shot, 67-foot high wall, 13 holes, 6 inch in diameter, 12-12 pattern. I can tell you everything about it. And we loaded the shot. I went to where the quarry scale house was, across the pit from it, and there was no cell phones, there was no CBs, there was nothing there at that time.
Right.
You just had an orange flag, and the one guy waved at the guy to shoot the shot, and Jerry McDonald was the blaster, and Jerry pushed the button, and October 9th, 1979, I said, that's it. I know what I'm doing.
You're hooked.
Once I saw that go off.
Yes.
Yeah, it was the most amazing thing I'd ever seen in my life.
Because it's one hell of a feeling, too. You're right.
I'm going to guess just a number, 6,000, 7,000, 8,000 blasts that I've done in the last 44 years. That's probably a fairly close number. Never, ever see a shot. I never say, okay, I've seen that, I'm done. No, because the whole dynamics of it is so amazing that you can take a solid and turn it into a gas and create that kind of work out of it. And just learn how to control that is just, yeah, it's really cool. Really cool. So
we just had lunch, actually, and you had mentioned that you have a personal goal of your own. You mind sharing that again?
No. October 9th, 1979 was the first blast that I was ever actually on. And my goal is 50 years later that I want to be blasting in 26 as well. And that'll make 50 years.
50 years in the industry.
Yep.
Now, you're not counting
26, but 29.
You're counting just the time that you were pressing the button, not the time you were making boosters?
No, just the actual blasting.
Okay.
Yeah, so October 9th, 1979 was the first blast that I was on. So October 9th, 2029 will be 50 years. So it's more or less just a personal goal because I just know that many people that have actually done one particular profession for half a century. So
That is
So
true.
how long was you in West Virginia before you moved on to the next location?
I was in West Virginia for 3 years, and then went to Western PA. That's when I went to work for Trojan. So Trojan then were split off. Nitrochem bought the NitroStarch side of it and started their thing up in Canada. And then Tommy Clark, Rich Barra, Paul Sullivan bought the booster business. And so I'd worked in West Virginia and then moved to Southwest PA to start a sales territory, which encompasses the Ohio coal fields, those kind of things. And then Tommy talked to, I forget who was the principals left at IMC at that time, and said, hey, he said, we want to talk to Mike about going to work for Trojan to sell boosters. So Tommy Kilmore met with me, and we sat down and talked. And so I started selling boosters for Trojan after that. So I did that for about, not quite 5 years, 4.5 years.
And you were bringing in to that area a new concept called cast boosters.
Yes. Yeah.
Yeah.
It had been dominated by nitroglycerin-based primers for forever.
Yeah.
I want to say that Trojan started the cast booster business in 1967. I think, Mick, was when they first made. They kind of did okay. They were still dominated by the NG-based boosters at the time. But so whenever Tommy Clark bought Trojan, of course, then it became a exclusive product for that company, and so they went out to change the industry, which they did.
They did.
And it was quite apparent. The thing that most folks don't understand is that the booster business was different than the dynamite business, because the booster business was designed to initiate what was around the booster, and the dynamite business was to create work itself. And that was the difference between the two. So most people associated better priming by bigger primer, which wasn't necessarily true, because the detonation pressure didn't matter if it was a pound or 10 pounds, the detonation pressure stayed the same. So the cast boosters then had 2 times the detonation pressure as what the dynamite primers did, and did a much better job of initiating the surrounding products. So it pretty much changed the industry.
Absolutely.
Whenever we went out and started selling boosters.
You were creating a new product just simply as a step function for bulk explosives, instead of having to have dynamite itself, which was the entire powder column. Now you had a cast booster, or instead of using dynamite to initiate AMFO, right? So a lot of that was the business. So you were going in specifically saying, okay, well, you already use AMFO instead of using
Here's
dynamite.
what does it better than what, because comparison, we could take a 1 pound cast booster and generate a faster burn in ANFO than you could with a 3x8 stick of dynamite. So we said that, we took it into the field, and then we started doing oscilloscope measuring velocities off of them, and actually proved it. Now, they had done several tests. This is all brand new, but just because we had something to sell, we had no idea how to sell it. So we started looking at it to see what the benefits of it were versus and it's pretty much open. I mean, they could have gone the other way. It could have just gone the other way and said, well, dynamite's where you need to stay, but it didn't. It worked out that the cast booster did a much, much better job initiating the surrounding explosives than what the dynamite did. So
this is why people
that's what really sold.
A Trojan booster is.
So the fallacy is this, and I'll never forget this. It was DC Gulick. Mick knows DC Gulick.
Yes.
And I was up in Pennsylvania trying to convert those. Now, this is a full line Atlas Powder Company distributor, full line. So I was trying to convince them to start using cast boosters. And they said, okay, Mike, we're going to test it. And I said, how do you want to test it? We're going to take it out and shoot. I said, okay. So we went out, and I remember the holes, I think, were 7. We went to Coalfield, and they took a 3/8 cast, or 3x8 dynamite primer, which they sold, high prime.
Mm-hmm.
It was the Atlas high prime, and a 1 pound Trojan cast booster. We put both of them in the ground side by side and stemmed the hole and shot it. And of course, the dynamite just blue rock everywhere, and the booster didn't even, just barely ruffled the ground. And they said, see, told you. Told you, much better process. I said, well, wait a minute. Come on. Drill me 2 10-foot holes. Okay. Now you want to do, I said, I want you to put 2 feet of ANFO around the dynamite. I want you to put 2 feet of ANFO around the cast booster. We shot them. Just the opposite happened. Because the booster did so much better of turning it. The ANFO was still at low order off of the dynamite, but it instantly went to high order off of the cast booster. So it proved exactly what we were talking about, was that it was the initiator that set off the ANFO, whether it actually, the work was to set off the ANFO or to do the work itself. Mm-hmm. And so that was the thing that just changed everything after that. Wow. We also used to do what's called a witness plate. And we'd take a 5/8 mild road steel 8x8 sheet, and I carried a bunch of them in the trunk of my car. And we go out and we'd take a 3x8 dynamite and stand up on its end, put a cap in it, and we shoot it, and it warped the plate. It did. It'd take the plate and just warp it up. We take a 1-pound cast booster, nothing covering it. Take a 1-pound cast booster and set it on. So you go out in the coal field and you just put a pile of drill cuttings, 8 inches high, just high enough to get the plate to sit on it. Now, keep in mind, the only thing that's in contact with that plate is the bottom 3/4 of an inch. So, because the cap is right down to the bottom of the cap well, right? Mm-hmm. So you had this much PE10 in contact with the steel plate. Get back 200 feet and shoot it, and it would shoot a hole the size of the booster right through the plate, not even warp it, and you could take another one and stick it right back through the hole. Mm-hmm. So it proved how much more effective the booster was at taking something from a solid state like ANFO and turn it into a gas. Yes. And we ran hundreds and hundreds of bloater tests, anything from 3.5 inch up to 12-inch hole.
And nothing works better than being on their mine site, taking these metal plates and saying, look, here it is, instantly, you know. Yep. I mean, there's the amount of people I've even seen in today's industry who've been blasters for a long time. They're not allowed to just shoot a booster on the surface. So they've been a blast helper for a few years, and now they're a blaster, and they use these products, but they have to use them in those applications.
Yes. If you ever get the opportunity to do that as a blaster, you should do it, because it gives you a total new respect for what you're handling. And absolutely, it's just, you don't, there's no way to actually tell how much effect that has on you unless you experience it yourself. Absolutely. Then it's just, yeah. It's really, real dramatic.
We had my first class ever with Dr. Wurzy was putting detonators under the wing of a chicken and blasting them to see what the effect. Now, they were already dead chickens. I saw, okay, Mick, they were already dead chickens, you know.
Okay.
I don't know if back in the day they were already dead chickens, but by the time I went to university there, they were already dead chickens. And it was to show the effect, because the bones in a chicken are similar to the bones in a hand. And so it was to show the effect of what actually the danger is here to a person, and how they used to crimp. You had to crimp your own detonators, and now they come crimped, you know, and that's a whole different thing with safety fuse and things like that. But then after that was done, we stepped it up to boosters, you know, and a stick of dynamite, just to see what the effect was on each one, you know. And so from a very fundamental level, I always knew what each one did. But then I got into the industry and I saw that you could work in a surface coal mine as a blaster for 10, 15 years, and the boosters always went off in the holes, you know, unless you were maybe got lucky enough to do some sort of a high-speed camera test where you put a booster on the surface, or someone wanted to do it just for some reason. So it was very unique to see it that way.
One of the things that I've seen over the course of so many years is that if you really, really want to know how explosives work and what it's capable of, you need to find enclosed construction blasting, because you get to understand what 1 pound of explosives is capable of doing. You go out to core and you shoot 350 pounds to a hole. You go on a big coal mine, you shoot 1,200 pounds a hole. You don't actually physically get to see what the capabilities of 1 pound or a quarter pound or a third of a pound of explosives is. So anybody that's actually in this and wants to make a career out of it, you really need to find a way to get involved in some in-tight construction blasting so you can actually, it'll amaze you, absolutely will amaze you what just 1 pound of this stuff is capable of doing.
That's a good point. And back to your boosters, you know, I had a misfire once where we had to test a lot of boosters, and that's where I learned about the misfire plate, and the witness plate. And it was very unique, and a lot of people don't know this, but if you go up to a blaster or somebody and you give them a booster, you ask them where do they think the highest pressure wave comes from, you know, and then they're going to point out to the side of, let's say they're holding a Coke can, they're going to point out to the side of the logo. They don't realize that actually it's the flat part on the top that has the most energy, and that's what's actually used to initiate the pressure wave for the AMFO or the emulsion, and not just the sheer mass of this.
No.
You know.
You could do the same thing, because we did this just to see, we did this several as well, is that we'd also take a 1 pound booster and lay it on its side and shoot on the same plate. It dent it and it'd crack it, but it would not burn through like it did standing on its end. That's how, again, when Ron Thomas and I were talking, we came up with the pancake boosters, because knowing that we maximize the surface area of the booster. And again, it's one of those sitting at the bar having a beer, drawing on a napkin, because we knew what it was, because we'd done enough motor tests that we could see what side priming did and what top priming did. So we knew it was there. So how do we maximize that? And so that's how we came up with the pancake primers.
And there's cone primers too. But I don't actually tend to see a lot of people using them. Was that kind of just because of
they're so directional, and that's
they're too directional?
Yes, they're designed to be that way because they're so directional. So yeah, between the pancakes and the cone primers, that's basically how that thing was developed. It was based off of the flat surface area, and knowing that's where you have the most bang for the buck. So the whole idea for the cone primer was that we could we could get the work out of a 3/4 pound booster that you would normally have a 1 pound booster for. So that's why now there's a couple of things that now I think they sell quite well, but back then you still had a lot of packaged product that was loaded in the bottom of the hole that was wet. And so you lost some of the assurance of the 1 pound booster by making it so directional that if it wasn't in the intimate contact with the packaged product, then the stuff might not shoot. So that's what changed.
The answer there, yeah.
The other thing is that you're talking about the size of the booster and whether it matters or not, is that I remember that Wampa was making a product they called Aqua Gel. Mick, I don't remember that or not, but
I do.
Yeah, at their plant. And they had a bunch that was 6 months old, sitting on the shelf. And so they had a test pond out back. And Paul would go out and shoot that just to see whether to shoot or not. And they always shot with a 1 pound booster. Well, they had a particular batch that they shot with a 1 and it failed. Don't ask me why he did it, but Paul said, well, I want to have a shot a 2 pound booster. So I took a 2 pound booster and it shot at full order. So there is something to be said, not only for the detonation pressure increase, but also the size of that detonation pressure increase as well. So you can take something that would be totally inert with a 3/4 pound booster and it would shoot at full order with a 1 pound booster or a 2 pound booster.
Well,
So
Mike, I remember is Trojan, I think, come out with the concept of matching the diameter of the booster to the diameter of the hole.
of the borehole.
And that pancake booster you're talking about was exactly that reason.
Yes.
It was larger in diameter than it was in height.
Yes.
Yeah.
Yep.
Good.
So I'll tell you a funny story. So this is whenever I was working for Trojan, and we gathered the kids up. We flew down to not Miami, Orlando. Had the kids there for Disney, whenever Disney was big.
Right.
And so Tommy Clark calls me up and says, I need you on a plane. And I said, for what, Tom?
On vacation, yeah.
Yeah, he said, no, you got to get on a plane. I'm in Orlando, Florida, right?
Yes.
Orlando, Florida. He said, and this is February.
Oh, God.
He says, I need you up on Iron Range. I said, what for? He said, Nitrochem, which was up there too, says that they have boosters that aren't going off. And that's a big deal on the range because you've got a small shot is 300,000 pounds. So it's a huge deal if you have a failure up there. So he said, get on a plane. I need you to get up there. I said, okay. So the heaviest thing I had was a freaking windbreaker.
Yeah, you're packing the flip-flops.
Yeah. So anyway, so I get on a plane and go up there. So I'm not in a good mood whenever I get there. So I rent a car. We go up. Thank God it was like only 24 degrees. So it was like a heat wave in the middle of February in Minnesota. So we go up to the magazine and God, I can't remember the guy's name now. But anyway, so I said, okay, show me the boosters. So he gets them out, shows them to me. I said, bring me a bag. What kind of bag? Just bring me a bag. So he brought me a bag. So I took one of the boosters, no, actually 3 of them. I took the boosters, put them in the bag, took a piece of 2x4 and just started beating the hell out of that bag. And they just started backing up away from it. I said, whoa, wait a minute. If this thing won't shoot with a blasting cap in it, me beating on a piece of wood is not going to make it go off.
Yeah, right.
So anyway, they said, okay. So then I took probably about a half a pound. I want to make sure it was pretty dramatic, maybe like 3/4 pound. So I took a sandwich bag out of one of their lunch boxes and I put the booster or the beat up booster inside it. I said, I'll bring me a blasting cap. So they went and got a blasting cap. I looked and I said, what are these? Well, this is what we do our tests for. I said, when were these manufactured?
The caps you're talking
The cap. They said, oh, I don't know. I said, well, bring me the box. 1969 was the manufacture date, the date code on the caps. So I said, do you have anything newer than this? This was like 1984. They said, well, yeah. I said, bring this to me. So they brought it to me, put it in, backed up, took a battery, and shot it. So the point was, it wasn't the booster. It was the cap.
And you're out there beating it with a wooden stick.
And these guys are backing up. I'm going, what are you backing up for?
Yeah.
If I can't shoot this with a friggin' blasting cap, this piece of wood is not going to have any effect on it.
And so that's at that point that that group of people learned that there's date codes on something for a certain reason when it comes to detonators.
Exactly.
They have a shelf life.
Mm-hmm.
Wasn't that amazing that was a big corporation? It was a high-profile blasting operation, and it's something as
simple,
as simple or as unique as date codes wasn't implemented in their program.
No.
Yeah.
I had the same issue with a big pipeline misfire that happened out in Arkansas, and I got caught out there. There was about 3 miles of unexploded products through this pipeline stretch on the. What's that called? On the working line. There's a term for it, but
I'm guessing that was Jared Reedike.
No, actually, it wasn't Jared Reedike. No, even though that's his stomping grounds.
Yeah.
And we were going through, but it was very irregular rock and irregular terrain. So it's not like you could just look at the heave of the pipeline, the trench shot. You know, normally someone said, well, of course you can see if there's a misfire there, but it wasn't, there was lots of the detonators that did work and some that didn't. So I think we probably pulled out like 50 over 3 miles. So at 5-foot centers, that's not very many, but it's still pretty bad when a shovel operator is digging and sees a stick of dynamite and something that didn't go off. And I'm trying to figure out what these date codes were. And they went and they found, they just had a few delay detonators that they hadn't used in a long time. So they've been rotating their stock. Like, you're legally supposed to rotate your stock, but they have these towers of their detonators of, 17 250s. But then they're like, well, we've got these other detonators that we haven't used in a very long time. And they got some weird delay that we had from another project years ago. And they had, it was only 10 years, but they were still using detonators that were 10 years old.
Mm-hmm.
And in Arkansas heat, in Arkansas summer, going through the humidity cycles and going through everything.
Yes.
There was failures inside the detonator.
I have personally shot 60% dynamite in Ontario, Oregon, which is in the desert, that was 10 years old.
Wow.
And used it for, but the point is, there is no humidity, so it's 0 cycle on the product. They had the coolest magazine I've ever been in. It was like a greenhouse almost, the way the thing was built. But anyway, we were shooting dynamite primers there that were 10 years old. To your point, there's a lot of difference between what cycle means in Birmingham, Alabama, and it does in Reno, Nevada. There's a huge difference in what that disparity is on cycles. So a lot of product that is manufactured today is so much better than the stuff that we shot years and years ago. I have not, to Mick's point, I've not been concerned about a misfire with non-L in years, simply because they've refined that to the point to where it's very, very difficult. It used to be that the first thing you suspected was the manufacturer, and now it's not. The first thing you suspect is the application of it, because they've gotten so much better at what their quality control.
And I can testify, I never dug out a Trojan cast booster. Did you?
No.
Never. I mean, you talk, because in explosives, reliability is actually number one. I mean,
Yes.
we talk about timing, frequencies, all this, but reliability is number one.
It is.
Thank you for listening to this episode of the Blast Report podcast. I want to thank the team at Blast Think for producing this show, and please follow along for more episodes in the future, and share this podcast with your colleagues so we can continue to honor our industry and the people in it. Be safe and have a blast.